Welcome back to The Explainer. Today we are going to get into the weeds on how the Vertica database absolutely masters one of the most fundamental and often slowest operations in all of data analytics, the join. Well, it all comes down to a really powerful and sophisticated approach to joining data. This is the secret sauce for high-performance analytics when you're dealing with massive amounts of information.
All right, so here's how we're going to break it down. First, we'll go through the standard join toolkit, the logical types. Then we'll get into the Vertica Edge, what makes it unique. After that, we'll take a peek into the engine room to see the algorithms doing the work. And finally, we'll reveal the real secret to speed, which is all about data distribution. Let's jump in.
Okay, so first things first, let's just cover the basics, the foundational join types that you'd expect to find in pretty much any SQL environment. And yes, Vertica supports all of them.
This right here is the absolute workhorse of the join world, the inner join. It's looking for that perfect overlap, right? It only gives you back rows that have a match in both tables. Think of it like this. You only want to see customers who have actually bought something. That's an inner join.
Now within inner joins, Vertica has a couple of handy variations. Natural joins are a nice little shortcut. They just automatically link up columns that happen to have the same name. And cross joins, they give you every single possible combination of rows. But a word of warning here, be super careful with those, because they can create absolutely massive result sets if you're not paying attention. But what about the data that doesn't line up? What if you need to find all the customers who haven't bought anything yet? Well, that's exactly where outer joins come into play.
With outer joins, you get to decide what to keep. You can keep everything from the table on the left, or everything from the table on the right, or even everything from both. And wherever there isn't a match, Vertica just fills in the blank with a null. It's an incredibly powerful way to spot gaps in your data.
And rounding out our toolkit, we have semi and anti-joins. Now these are a little different. They don't really combine tables. They act more like a bouncer at a club. A semi-join answers the question, hey, show me all the products that are on the sales list, while an anti-join asks, show me all the products that have never made it onto the sales list.
Okay, so that's the standard stuff. Now let's get into the good part. What really gives Vertica its edge. We're moving beyond basic SQL now and into some specialized tools that are built from the ground up for high-speed analytics. Vertica has some really clever strategies for tackling tough analytical problems. We're talking about things like intelligently joining time series data with messy timestamps, or even pre-calculating the joins so your queries are practically instantaneous. Let's dig into a couple of these. Now it's so cool. Check out the interpolate feature. Imagine you're trying to join sensor data with weather data. The timestamps are never going to line up perfectly. Well, interpolate handles that. It intelligently figures out how to compare the two series without you having to do all that painful data cleansing first. For anyone wrestling with time series data, this is an absolute game changer. And this one is just a brilliant idea. Pre-join projections. Think of it like doing your homework before the test. Instead of making the database join huge tables every single time you ask a question, Vertica does the join once when the data is first loaded. That means when you finally run your query, the answer is already sitting there waiting for you. So we have the what, the logical join types, and the special strategies. But what about the how? How does the engine actually perform the join? Well, under the hood, it's usually choosing between two main algorithms.
See, Vertica's Query Optimizer is really smart. It looks at your data and asks a simple question. Is this data already sorted on the columns I need to join? If the answer is yes, it uses a super fast and memory-efficient merge join. If the data is all jumbled up, no problem. It switches to a hash join, which cleverly builds a quick lookup table in memory to find all the matches.
And this brings us to the final, and I would argue the most important piece of the whole performance puzzle. Where your data physically lives across the cluster.
Okay, if you remember one thing from this explainer, make it this slide, a local join. This is the holy grail. This is what you want. It's when all the data needed for a join is already sitting on the same machine. And why is that so great? Because it means there is zero network traffic. On the other hand, a distributed join means the database has to shuffle data between machines over the network, and that network hop is almost always the biggest bottleneck.
You know, the source material had this fantastic analogy that just nails it. A local join is like having all your left shoes and all your right shoes delivered to the same loading dock, already organized. You can just pair them up right there, super fast. A distributed join? That's like having your left shoes in one city and your right shoes in another. You've got to spend all that time and money shipping them to a central warehouse before you can even start pairing. That shipping time, that's your network overhead.
So what happens when a distributed join is just unavoidable?
Well, the optimizer still has a couple of tricks up its sleeve. If one table is pretty small, it'll just broadcast it. Basically, it sends a full copy to every single machine. If both tables are huge, it has to do what's called a resegmentation, which is this big coordinated data shuffle to get the matching rows onto the same machines.
Okay, let's bring this all home. We've talked about logical joins, special strategies, the algorithms, and data distribution. But why does any of this actually matter in the real world? Well, Vertica's incredible speed doesn't come from just one magic feature. It's the synergy of all these layers working together. It has a flexible set of tools, it knows when to use a specialized strategy, and most importantly, its execution engine is always thinking about the physical layout of the data to find the path of least resistance, the path with the least amount of data movement.
So I'll leave you with this final thought. Understanding how joins work under the hood isn't just a fun technical exercise. It should fundamentally change how you think about designing your data models. Because if you can design your tables in a way that allows the database to perform local joins, you're not just tweaking a query for a small speed boost. You are building a foundation for an entirely different level of performance.